Question 11 on permutations and combinations. Part A is about points on a circle. Every pair of points joined by a line gives 4n lines, and we count the polygons we can form. Part B puts 10 boys into a dormitory of bunk beds with a few conditions. Here is what we are given: the points and lines for Part A and the dormitory setup with the twins for Part B. And here is what we must find: the number of polygons, then the arrangements with no restriction, and finally the arrangements with the weight and twin conditions. So here is what we are working with. For Part A, points on a circle and a count of lines. For Part B, 10 boys, 10 beds, and the twins. We will take the 3 answers one at a time. Let's picture Part A. We have a set of points sitting on a circle. Each straight line simply joins 2 of the points. So the number of lines is just the number of ways to choose 2 points. A polygon needs at least 3 points. 3 points make a triangle, 4 make a quadrilateral, and so on. So counting polygons means counting how many ways we can pick 3 or more points. Section 1. First, we use the line count to find n. A line joins 2 points, so the number of lines is the number of ways to choose 2 points from the n plus 1 points. That count is given by the combination formula. We are told that equals 4n, so here is our equation. Writing out the combination gives n plus 1 times n over 2. Clear the fraction and bring everything to one side, and it becomes n squared minus 7n equals 0. Factor out the n. A circle of points can't have 0 of them, so we reject n equals 0. That leaves n equals 7, which means 8 points on the circle. Section 2. Now we count every polygon those 8 points can make. Here are the 8 points. Each polygon is just a choice of 3 or more of them. This triangle uses 3, this quadrilateral uses 4. So we add up the ways to choose 3 points, 4 points, all the way to all 8. That is the sum of these 6 combinations. Working each one out gives 56, 70, 56, 28, 8, and 1. Adding them together gives 219 polygons. Section 3. Part B, Question 1 with no restriction at all. There are 10 boys and 10 beds, 5 on top and 5 on the bottom. Pick any one for the first bed, 10 choices. Then 9 boys are left for the next bed, then 8, and so on, right down to the last bed with just 1 boy left. Multiply all those choices together. That product is just 10 boys arranged in 10 positions, a permutation. Which is 10 factorial? 3,628,800. Section 4. Part B, Question 2, where the conditions kick in. Here is the weight table again. First, who weighs more than 50 kilograms, B at 52, E at 66, G at 61, and H at 56. These 4 must each take a bottom bed. Next, the twins A and B must share a bunk. Since B is over 50, B takes the bottom and the top of that same bunk, so their 2 spots are locked in. Now we count, 1 stage at a time, then multiply. Stage 1, which of the 5 bunks do the twins take? 5 choices. We drop A on top, B below. Stage 2, the 3 heavy boys E, G, and H must fill 3 of the 4 remaining bottom beds. Order matters, so that is 4 permute 3, which is 24. Stage 3, the last 5 boys, C, D, F, I, and J, fill the 5 seats that are left in any order. That is 5 factorial, which is 120. The stages happen together, so we multiply, never add. 5 times 24 times 120 gives 14,400. Final answers. Part A, 219 polygons. Part B, 10 factorial, which is 3,628,800 ways. Part B, 14,400 ways.